All right, now that we've talked about Newton's law of gravitation, we can start talking about Newton's second law, which says that the acceleration of an object, as produced by a net force, is directly proportional to the magnitude of the net force, in the same direction as the net force, and inversely proportional to the mass of the object. That is to say, a bigger force makes a bigger acceleration, a bigger mass makes a smaller acceleration. The second law can be stated like this. F net, a net force acting on an object, equals mass times acceleration. Now, the net, this matters a lot because it's not just a matter of a force acting on an object. Often there are two or more forces acting on an object, but they're in balance, and so this net force means a force that is not balanced. Now, let's look at the units of force. Force equals mass times acceleration, and if we look at the units of mass, which are kilograms, and the units of acceleration, which are meters per second squared, then we get that force, which is often specified in newtons. We have that a newton equals a kilogram meter per second squared. So what this says is a newton is the force required to accelerate a 1 kilogram mass 1 meter per second squared. That is to say, when this 1 kilogram mass starts, it's going 0 meters per second, and you push it hard enough that after 1 second, it's going 1 meter per second. And so let's look at an example. We've got a 1,000 kilogram elephant and a 10-gram mouse. And let's find out which one falls faster. In this case, let's ignore air resistance. All right. So that's valid in the first few seconds before the mouse reaches terminal velocity. Terminal velocity is the speed at which an object stops accelerating because of air resistance. So in this case, we're going to ignore air resistance. Which one falls faster? Now, if you go back to the gravitational equation, remember that mass is directly proportional to the force. And so this heavier elephant will have a greater force acting on it than this small mouse will. Because of that greater force, you might think that the elephant accelerates faster than the mouse. That is not correct. Because even though the elephant has a greater force, its mass is also greater. And so rearranging F equals ma, we can restate that to say that A, or acceleration, equals force over mass. And in the case of the elephant, this large force is offset by the fact that its mass is greater. For the mouse, there's a smaller force due to gravity acting on it. However, its mass is also smaller, and when you take both factors into account, you'll see that the acceleration in either case is the same. So acceleration for the elephant, 10,000 newtons divided by 1,000 kilograms equals 10 meters a second. Acceleration for the mouse is looks like a force of 0.1 newtons divided by a mass of 0.01 kilograms, again, about 10 meters a second. In fact, the accepted value is about 9.81 meters per second squared. That's the acceleration due to gravity. In this case, we're just rounding to 10. it's important to note that no mice or elephants were harmed during the production of this PowerPoint slide.